Good morning, everyone. Or good afternoon, or good evening, wherever you are. It's morning for me. We're going to work on HDX for a bit. Oops, we have. Let's cargo watch -x test all features. Look at the Lexa. So I want to try and figure out some of these parsing errors. We got some parsing errors here, and they should be pretty easy to resolve, and hopefully people will learn about how well this parser works at least. So I'm going to tweet and post and toot and skeet about it first. You have to watch me do that live. Pulling up the YouTube so we can read the comments as well. Let me also do this so that we can. My head isn't in the way of output. Right. We are getting ready. Indie Web Social and new post. There we go. All right, we can hack. So the first problem seems to be Lexa. I think it's in the lib. Let's have a little look. What is the issue? Index 4 is out of bounds. So the source in this case is A and then this character, which I believe is /1000, but we will see. Char code at 0 to string 16 D800. What am I even doing now? 2 string 16 is D800. Unicode D800. Is a high surrogate. And this is the problem with these. Some of these surrogates are a little tricky to parse because they take up multiple Unicode characters. So 273 and as usize parse. So it's not ASCII returning. This is the character and the UTF length of 3. And we were manually parsing 10A and then this symbol. So this is a dimension. and then there's A, and then the symbol. Oh, but then we're on escaped. This is a different one. This passes successfully. I've completely missed this. Escape code .001 is the issue. So we need to somehow parse this, and it's not parsing. So it's not ASCII. What is it? So it's // so it's a null byte character is the problem. Like, I think this is a /0. But for some reason it is whoops. Do not know why I've ended up in here. How's escape sequence? If we look at the C as U8, it might help. So we've got this character. I think it's a null byte character, and it's returning as 3. It's 253. What is 253? I don't believe that. Let's look at this escaped code .0001. It is just the / character, I think, is tripping us up here. Oh. Is it a replacement? So the CSS spec replacement. The CSS spec has a very interesting let's see here. Replacement. The CSS spec says any null or surrogate code point in input should be replaced with this replacement character, which I believe is this 253. Yeah. So what is happening is, because it's just a /, we're hitting the end of the line. We're feeding in the replacement, but the problem is the replacement. We're at the end of the line here, and then we're still passing in the length of this character as if it exists in the token stream. That is not the case. So what we need to do is say if let sum. Why do we mutate this? We don't need to mutate this. If let sum. So this is the escape sequence. We're going to say get the characters from the start point. If the character exists, if it's not a hex digit, we want to return it here. Otherwise, we're going to keep consuming characters. We can just do this here. Let mute CC. If it's white space, we'll continue. If it's in the surrogate range, we need to return the replacement character. Otherwise, we're going to do that. Otherwise, we're going to return the replacement character. Zero. So this is the end of file case. That should fix this. And it looks like that's fixed this. But now we have this other issue. /t. And so what is this one? This one is... this one is whitespace 008. Which is a slash space, a slash tab. And so we should see this is fine. This is weird. Oh, this is the /t. So we find the /t, which is not ASCII. We return it. We see the O. Then we're saying CSS tokenizer test 255. CSS tokenizer test Rust 255. Oh, this one is parsing. Let me get rid of these debug statements because they're littering the logs. We still have 19 failures is the point of this test. I'm gonna decorate that with a statement. Should have 0 failures, but tests failed, fails. So string 005 failed as a test. So if we look at string 005, it has a backslash and then a null. So parse string, parse through. We see the backslash. Maybe I want to introduce these debugs again. We'll just go hunting in the logs. So, we should have reached this point. We should have reached parse escape sequence. Let's put a debug here. Let's just move this here. Get rid of that. So that should... I wonder if this test is valid then. We should go look at the string CSS syntax. Consume string token says there's a special bit here that says if the next code point is EOF, do nothing. Just for strings? Just for strings. Good stuff. Is string then? Maybe we'll just say kind, which could be a kind. So when we parse an escape sequence, we need to know the token kind. So that when we, else if kind is not equal to kind string, because in a string I guess we just zero as char as car. That doesn't feel right, but oops. Thinking this is JavaScript for a second. We're still at 19 failures. Definitely thinking this is JavaScript and putting parentheses around if statements. Right, please. So in the case of a string, when you encounter a slash and then it's the end of the file, you're supposed to just do nothing. Like, that's what the syntax said, right? Do nothing. What does do nothing even mean, you know? I guess one way we could do this as well is rather than do this here, in parser, we can say if kind token 9 bits is well, so geez, if C is escape, if self string self source len is equal to I, and token bits is equal to kind string as you wait. So here's the condition, right? If we're at the end of the file and it's a string, well, we pretty much feel like we want to just skip this work. So we want the inverse condition. If, I mean, I don't like that, but I guess one thing we could also do is just continue here. or even break. And let's link this bit. So what is actually going on here? It says this. So when the token is a string, escaped EOF points are not consumed. Okay. Ugh. The tokenization of CSS is really tricky. There's some bits that just do not float very well. Do this. Come on. We want to see this number go down to 18. Why? What is going on? Maybe we're not hitting this. Debug. Token. Kind bits. Let's check this as well. Let's just do. This is my debugging capabilities. I don't really get on with GDB, so I just do this line level debugging. Carmack be damned. What are we looking for? We're looking to see. Oh, because I moved that I, this is probably no longer true. This should be like I plus 1. But we'll see what this logs. Yeah, it's false. So I think if I did I plus 1 here. Oh, that's the wrong one actually, isn't it? It would be, we want to look at this one, which still has no logs, which is curious. Why does that not log? I would expect to see some debugs between these. Let's do no capture. Maybe maybe the logs are coming out in different orders or something because of Rust's test thing. Nope. Okay. Part of me now wonders if this particular token is maybe getting hit here. So let's find out. I wonder if somehow the actual tokenizer isn't correctly flagging it as containing escape characters. And yes, that is the case. So we go to consumer string token. Here's the EOF case. And we just need to add this. That should fix it. We'll find out. It hasn't fixed it. So now it's doing the null byte. I +1 is false. Maybe I didn't need the +1. The amount of off by 1 errors I am running into with this Lexer is concerning. Still 19. Okay, so we do contain escape characters. Thank you for that. Parsing, we see. Oh wait, is this the same? This is the same. Source len is still false. Okay, let's log these two out and see how far off we actually are. I is 2 and len is 4. Let's make this peekable. Let's say source this should be self. No, this should be cars peak. Let's just debug the whole cars peak. And here, I think we want to say cars peak is none. This needs to be peekable. This needs to be cars. Okay. This is it then. 18. We've passed the test. String 4. This has probably the same problem. Let's have a look at if it's a new line, it's a parse error. Reconsume the current code endpoint, create a bad string token and return it. So if we go to the Lexer, we should say is new line. Oops. So is new line. We should return a bad string. I think that's correct. But this isn't a bad string though. This is a kind string. Oh, this is an escaped new line. Have we just made more errors? No. I'll still undo this change because that feels weird. Okay. An escaped new line in a string is valid. So what is actually going on here though? Let's open this up. String 004 CSS. Okay, so we've got a close quote, which we are not consuming for some reason. And so that's going to be in here somewhere. So if the car is a new line, we consume and then we continue. This looks fine. So this is the bit we're at, right? We've got this slash. go back to the syntax thing. If it's a new line, well, it's an escaped one. So if the next code input is a new line, consume it. So this is the problem. So if we go back to, let's get rid of some of these. Need these. So we got the same problem here, which is, so let's say string has special roles. So when the token is a string, escaped EOF code points are not consumed. We also want to say oops. Else, let's say let's see equals cars peak. I'm going to say C is none here. This one is going to be if let some if C map is new line, unwrap or false. Let's put this here. So if the next code point is a new line, consume it. So I plus equals 1 continue, because we don't want to append it to the string. We're also, because we're doing a string builder, we need to say if stir, if let some mute stir equals stir. No, we want to say if stir is none, we need to create this string effectively again. Stir. I think this is right. Yeah, let's see what happens. 18 failures still. Okay, so let's put a debug here. Oh wait, we're false still. I think in every case, when there's an escape character on a string, we want to say, we want to push the parser into this mode, so we need to set that flag. Oh, hey Meringue. Okay, yeah, cool. This is good. So here's string 4. It contains escape characters. This is the string where it's got /n. This is still broken though, because in something around here is going wrong because it's not getting the O after. So the end position is wrong here. Another off by 1 error, I think. We're still at 18 failures, but I bet this is better now. Yeah, so we've got the O. So it was the off by 1 error. So it is a string. We see the new line. This is all fixed now, but the structured value still contains the new line. And this is probably because this isn't working out as I had hoped. So let's debug stir, which should be none. Let's also debug, whoops, this. Mind recapping what you're doing at this moment? Yeah, cool. So there's a test suite that we've got, which has a bunch of tricky cases for lexing. So we're running through the CSS syntax spec. This is the spec, and we're trying to make sure that everything tokenizes correctly per all of the spec. And this used to work, but I rewrote it because I am a dum-dum. I rewrote it because I thought I could be more efficient with things by skipping a bunch of the allocation work during lexing and only do it when it's necessary for parsing. But in doing so, like the old code... Nope. Yeah. The old code in private TS, in private RS, I'll zoom in a bit as well, make this a bit more palatable. Whoops. Parse string. So the old code does this copy on write stuff. Oh, that is messed. Does this copy on write stuff? Maybe I'll go on raw. No, that's even worse. Oh damn! I'm not going to select anything. So we create this copy on write string, and then when we get to these new line characters, we start doing different stuff, right? And so I've had to pull apart the copy and write stuff because I don't want heap allocations during lexing. Ideally, the lexer should just chew through tokens and just give you ranges, and then you can determine, because there's not always it's not always the case that you want to do something with a string, right? And so it shouldn't waste time building out the value of the string if you're like, I don't even care if it's not a string, just skip it or whatever. So the idea was to pull it out into a separate method, but in doing so, I think I've broken a bunch of stuff. And one of those things is this particular test. So we need to do a reference here. So one of the tests that has failed is this test, which is string 4. So string 004. So we've got this CSS file. This supposedly is it might not be valid CSS, but it should at least tokenize, and the token should be the letters FOO, because it shouldn't consume the new line. So if we go to the spec, we read this, it says, when you're consuming a string token, if you encounter a slash, which is this bit, if the next code point is a new line, consume it, and consume it in the context of the CSS syntax is like skip it effectively, because you're consuming the character, so you're moving to the next character, but you're not appending it into the string return value. So that used to work, now it doesn't, and I think it's because of around this line. So stir is a sum with FOO. Oh, because it has just been created. Oh, we just need to do cars next. No. Yes? I think yes. I think this is right, maybe. Let's see. So hopefully this number goes down to 17. Even better. It went down to 16. Let's hope that keeps happening. Alright, so this is the next tokenizer failure, and this is numeric 002. Which is -123.753 e minus 2 pixels. We are mistakenly assuming this is an integer. Yeah, down 16, let's go. This is obviously not an integer. I don't know why we're assuming it's an integer. So if we go to consume numeric token in this godforsaken code base, somewhere around here, strangers position. I think that the was it 004? This makes sense, right? Because if you had like a CSS that was like, you know, my very long string, and you wanted to break it into new lines, you can just escape it, and it can still be a valid string token. So this kind of makes sense from that standpoint, I think. Yeah. This one should make sense though, because this definitely is not an integer. I don't know why it thinks it is. So the way tokens work, we go to struct token. Nope, enum token. Something token. We have a set of token flags, and there's this whole thing that I've written which says the first 3 bits of this token flag bit mask. The third bit here, if this is 1, this means that the number that the token represents is a floating point number. So we should have in places flags or equals 0b001. So if we encounter a dot, it's obviously a floating point number, and so we should flip the floating point flag. If it is a if it has an E, like a scientific notation, the exponent, it should also have it should also be set to a float. So why is this particular number not being set to a float? This is a dimension. Not that it should matter. Dimensions have the same property. Yeah, if it's a number or a dimension, right? So this is if the first character is a dot, which it's not, it's a minus sign. So we should be here. So let's put a debug. Nth car. So we're saying it can't be a float already, right? Because if it's a float, it means we've encountered the dot, and so you can't have two dots in a number. So this would just be invalid. But also the second car has to be an ASCII digit. Where he says, TIL, you can break strings on new line, makes sense for grid area, I suppose. Always thought you could just press enter and then your string would contain a new line, whereas the slash would not. Yeah, there's a provision for new lines, which means that it's a parse error. If it's not escaped, it's a parse error. Whoops. So if you did like use CSS, if you did foo bar, this is a parse error. This will still consume tokens because the lexer should never fail, but this will be tokenized as a bad string, and then you'll get a new line, and then an ident, and then a bad string. Yeah, the lexer has like concepts in syntax. In the syntax spec, it has this concept of bad string tokens. All of the tokens include like, well, some of the tokens include bad variants. So there's bad string and bad URL. What's the time? Oh, we're close to the hour. I need to go do day job in a bit. Okay, so let's figure this out. Why is this an integer? So when we tokenize this, we see the dot and the 7. So let's debug format 10b flags. Let's debug the flags and make sure that that flag is set. Yep, it's set. So maybe something is going on in the token. Is float. Self kind bits. We need to format this as binary 08b. Let's check his float as well. Huh. Oh, yeah, wait, that's the flags. Where's the kind bits? Here we go. So the fourth bit is set, which is what we're checking for. That means it's a number or dimension token per this absolutely unhinged thing that I've created. We look here. Number mask is the, I guess, you could call it the third from the right. So yeah, third from the right is set. So it is it is set as a float, but for some reason we're not actually setting it here. So I'm just really weirded out by this. So tokenizer. We have a way. This test case is kind of weird, but because these, what is this one? This one is, what was this one called? Number something. Numeric 2? Numeric 002. Yeah. So this is the CSS file, and then there's also a JSON file that represents what should be tokenized here. And so you can see what we do is we normalize the JSON because we don't store all of this data, but we still want to use it for tests. This test is written by someone else. We still want to use it because it's a useful test suite. So what happens in the tokenizer tests is that we kind of fudge some of the data. So we delete some properties, or like we just don't parse them. But I'm wondering if somewhere in here, in the dimension, so we say if it's an integer, it should be the string integer, otherwise it should be the string number. But we saw is int. So let's see, is int. So is int is true for some reason. So if we separate these conditions, maybe we'll learn more. Third bit is set. So the third bit is third bit is set is coming back as true, but that's not the case, I'm pretty sure. I'm weirded out now. It's confusing. So the third bit is set. So why is third bit set? Flags 29. Why is it coming back as not? So this should return true. This should return true, not... And notting it should return false. Something weird is happening. Third bit is set as false. But if we look at the flags... Shift this right by 29, just to get the 3 bits. Now it's 0. What is going on? I'm very confused right now. Oh. This is not right at all. Where do we make this token? We make this token in new dimension. Debug the flags here then. Debug. Let's debug the type flags. Type flags. And let's debug flags entirety. Oh, lexing is a real drag. Once the lex is like solid, everything else is fun, but lexing is like, oh no, this one character is off. So here's the start of numeric 2. So the type flags are all zeros for some reason. I'm out of time though, aren't I? Well, I'm gonna have to pause this and pick this up later. I'll probably finish this in the evening though. We've only got 16 tests to go. So maybe next stream we'll do something fun and do some parsing of actual CSS rather than tokenizing. But thank you very much for watching if you have been. I'll see you around.